All right, this is finding the domain and range using the graphs. And so I have three basic graphs here that we're going to use to find domain and range. And then we're going to use the graphing calculator to find the domain and range. So for domain is our x values. So we want to find our x values. So the way you do this is you focus on the x-axis from here to here for our graph. And you move along the graph until you hit a point. There we go, we have a point. And what you do is you draw a dotted line down. And you mark that point. So 1, 2, 3, 4, 5. It's -5. And the points will sometimes be given to us. Like this is -5, comma, 1, 2, 3, 4, 5, 6. Right there. So we know our first x value will be -5. And it is a closed dot. So we put a bracket to mean include. So brackets, again, this means includes. And parentheses doesn't include. And then we just move around along our graph. We just keep going through the whole thing. So our graph will go from here, and we still have x values. See, there's a translated x value right there. There's more x values, right? We just all the way up. There's an x. And it stops here. This is our last x value. And that point may be given as well. So it's 1, 2, 3, 4, 5, 6, comma, 1, 2, 3. But this one is not included. You see how it's an open dot? So our x values go from -5 to 6, and that's our domain. And now the range is our y values. And so we start on the y-axis. That's our range. But you always want to start with the y. You always want to start from the smallest to the largest. X is easier because we already know left to right. Y is top to bottom and bottom to top. So if we move up the graph right there, that's our first y value, which is 3. Right there, 3. And then if we move up this graph, we have y values. See, there's a y value here, a y value there. There's y values all the way up until we hit to here, y values. See? And so our highest y value is 6 right here. So our range would be from 3, -3, again, open dot, to the highest value of 6, bracket. And so that's how we use our graph. The range is the lowest to highest, highest to lowest. What if we have arrows? So if we move along to the side here, again, that's our first point, but it's not really. Our graph's going to go on forever. So if we were to look at this arrow goes on forever. It would look like this for our x values. Right there's where it stops now, but the arrow means it goes on forever. So it's going to go on forever that way and forever that way. So we really have an arrow here this way and an arrow here this way. So our domain would be -infinity to +infinity. That's what this is. This is -infinity. This is +infinity. You never want to include them. They are always forever. So there is no bounded area. It goes on forever. Parentheses only with infinities. Now our range. Range is a little different. We do have a lowest point here, and that's 1, comma, 1, 2, 3, 4, 5. So it's at -5, right? Grab the negative on that one too. So from -5, let me get the blue out. And so this one goes up forever. And again, it's going to hit an arrow. And so that means it goes on forever. That is +infinity. So our range here would be bracket -5 because it is not an open dot to infinity. We're only getting open dots. We're only getting parentheses at open dots and infinities. Like that, arrows. All right, this is the last type you'll have, and we have a gap if you notice it here. So again, we shade over here, but that goes off to -infinity. So our domain would be parenthesis -infinity. And then as I shade across, we get stopped right here. And we wonder, is that included? Well, we're just looking, is there an x value? So you're saying, is there a -10? Yeah. Is there a -9? Yes, there's a -9 here. There's a -8, a -7, a -6. There's a -3. See right there. And then there's a negative right after the 3. So -2.8, to -2, -1. All the x values are represented. So this one right here is closing in that dot. So since it closes it in, it goes on forever. So if these were both open dots, then we would stop here and have a stop, but it's not. So it goes on forever. So this is actually a negative infinity to positive infinity because that open dot fills the gap that we have at -3. There is a value of -3 comma -2. So since we have an x value, it goes off from negative infinity to positive infinity. Now the range. The range again is down here. We go, see the arrow means we go down to negative infinity. I know I changed colors, but, and then we go up and then boom, it stops. So this one is actually stopping at -2. So our range already has one little problem. It's not a problem, it's just a stopping point. We put that. And then we put a union symbol. And then we go back to see where it stops. So it goes from negative infinity to -2. And then there's a gap here until +1. And then at 1, it continues on again off to infinity. And I know it's infinity because there's an arrow. So it goes off to infinity. So we put a union symbol and then parenthesis at 1 because it's not included. And then infinity. That is the most complicated one I could think of. So it's included here from negative infinity because there is an x value. Remember, we're just listing, is there an x value? So there are x values from negative infinity all the way to infinity. But for the y values, there's only values from negative infinity to 2, including 2, -2. And there's no y values in here, none. There are no y values. There is no y value of -1 on our graph. It does not start again until 1, and then it goes from 1 off to infinity. All right, so to give you an idea of how this works, I have a nice quick little graph here. So if we follow our little cursor, you can see these are my x values. My x values, just look at the x coordinate, only goes from negative infinity all the way to here, and then it jumps, right? But if you look here, you would think, oh, there's no value there. But at 2, we do have a value. See, at 2, there is a value. So there is an x value from negative infinity all the way to positive infinity as it goes off to infinity. And that's why we are getting this negative infinity to positive infinity. Now if you look at the y value goes to 1 right here. And then it jumps. So it goes from a y value of 1 to a y value of 5. So we get negative infinity to 1, bracket, and then from 5 to infinity with a parenthesis. So that's where we're getting this. So here it goes from negative infinity to -2, and then it jumps to 1. So the y value goes from negative infinity to -2, jumps 1 to infinity. So when you see that split, if there is a value there, you have to include it. So these are the ways they're going to give you graphs, but then also they're going to give you functions. And when they give you a function, you're then going to take it and you're going to plug it into Desmos right here. So I've already plugged them in. Here's our f of x equals x squared plus 2 minus 5. And we know it's an absolute value of x, so we already have our v shape that we're looking for. And so we're just going to translate that. And what we need to do is find points. So remember, we want the lowest point. Intercepts are fine too, but we don't need them for domain. For domain, we need that lowest point. And so we're going to take that -2, -5, and transfer it. We don't even have to put anything else on there. We just need our graph, nice rough sketch, -2, -5, and then we have to go back and check it. Yep, looks good. Check it one more time, -2, -5, yep. And then now we can do our domain. So our domain here, these are our x values. So what is the farthest x value we have? So that's going to be an arrow, right? And so we're starting over here, and our graph, we have x values all the way across from there to there. So we have an x value from -infinity to positive infinity. Now our range. Our range is down here. This is our lowest point, right? And that's -5. And then from -5, it's going to go up again to infinity, as red. So our range would be from -5 bracket, because it's not an open dot, comma, infinity. And that is all of our values. And if you look at Desmos, you will see that. We have x values. If you just drag it across, our x goes off to infinity, -infinity comes down and then goes off to positive infinity. See? And then the range starts here at -5, and then if you look at the y values, remember the y values are here and here. We're going from -5 to -3 to 0. So our y values are increasing off to infinity. See, they're going up to infinity. So our x values go from -infinity all the way to positive infinity, just focusing on the x value, and then the y value goes off to infinity. All right, so I want you to try the next one. Plug it in the calculator and try it. It is a complicated one. So hit pause and try it. All right, now that you've tried it, you should have had that graph. There's our graph here. And if you look at it, you see we're going up to some number. It's coming from negative, and then the other side is coming down to some number. Well, it's actually at 0. There is no value of 0 here. And then in between, you can see that there is no value of -1. See, it's going towards -1. You can even check it with a point. Remember, we did this earlier. -1, comma, and then I'm going to do g of -1. And label. And there's nothing there. There is no value at g of -1. There's nothing there. It's undefined. In fact, you can even do a value. And you see it says undefined. There's no value at -1. So when you have rational expressions, especially our basic, this is our parent function, we have two undefined values, one for x and one for y. So when you have a rational function like this with just the x on the bottom, it's a guarantee that we will have what's called a vertical asymptote and a horizontal asymptote. You will have a gap in here. And if you remember, we did domain earlier. So x plus 1 cannot be 0, which means x cannot equal -1. We have a gap at -1. And then this one is actually y equals 0, and you could pick that one out as well. So for our domain, we're going to go from the left to the right, just like before. Let me grab my yellow. So coming from the left to the right, see there's our arrow. So we know it's -infinity. And then we go all the way to here, and then we stop. So at 1, we are stopping at -1. And then we will start right back up at -1 for the other side. So what you are giving is the domain of the graph to the left of -1 and the domain for the graph to the right of -1. And there's our domain. So it goes from -infinity to -1, union, -1 to infinity. Now for the range. Range is the same thing. We're just working from the bottom to the top. So it comes down from here up. So that's -infinity. And then again, we're stopping at 0 and then going back up. So infinity. But in here, we stop. And you want to put a parenthesis, and that's 0. So it goes from -infinity to 0, union 0 to infinity. And if you really want to see what that value is, if we take and plug it in, if I plugged 0 in for my y, this is y equals 0, see it? And I try to solve it, right? Multiplying with a little cross multiply, you get 0 equals 1. That's not true. That's the whole idea. There isn't a value that will work. So 0 times this would be 0, 1 times 1 is 1. There's nothing. There's no x value that would ever make this equal to 0. I can't plug any x value in to make that 0. It's impossible. So that's our values. So that is everything. You have your graphs, and then you have to plug it into Desmos to figure it out. And these do take a little bit of practice, but eventually we have your parent graphs from the previous. You will see everything. Thank you.